Welcome once again to our channel Physi Dive, and this is your teacher alexi Rajan. Today we are going to study a very important topic of class 11, motion in a straight line. So in this chapter we are going to study about various topics related to the motions in a straight line. So what happens when one object is moving along a straight line, and what are the importance of this particular motion. These are all things we will learn in this particular chapter. So let's dive in straight to the class. So to the class. Motion in a straight line. So in this chapter, we are going to study about the movement of an object moving in a straight line. So before starting the class, we need to study some basic ideas about this particular chapter, some prerequisites. So first and foremost thing is that the mechanics. So what do you mean by mechanics? Simply, it is a branch of physics which deals with the study of an object which is moving or which is at equilibrium. So what do you mean by that? So just imagine that there is an object here, an object A, which is moving in time t. It is starting from point A, okay, and after time t, you can see the object is at point B. Okay, right. So we need to study about the movement of that particular object, and we call it as the branch of such type of movement as mechanics. So in mechanics itself, we can say that there are three subdivisions. So mechanics can be divided into three. What are those? First one is statics. Second one is kinematics. And the third one is dynamics. So what do you mean by statics? Imagine that you have an object here. Once again, I'm taking one object here, okay, and this object is at rest. So it is not moving. It is not moving. That means there is no external force acting on such object or body, and we call it as the body is at static position. Or we study whenever we study about the condition of that particular object, we can say it is a statics. We are studying about the statics of the object, or simply, in other words, other than rest, we can also say that if a force is acting from this side, let it be F1, and let another force F2 act on the same object, and these forces are equivalent, their directions are opposite, then also you can see that the object will not move, because in a tug of war you can see that if okay, this is your team, you are a team of three, and there is a rope, and your opponent is of three. So there is a tug of war. And you can see that if both the teams, this is team A and this one is team B. So if both teams are applying equal force, then you can see the tug of war or the rope will not move. It will be at statics. So we can say statics, you can say statics is a study of an object which is at rest or which is at equilibrium position, on which many forces, external forces, are acting upon, and these forces are probably equal and are in opposite direction, so they cancel out each other and they will be at rest itself. So that's about the statics. So what do you mean by kinematics? So kinematics is a branch in mechanics itself, sub branch of mechanics, where the study is on the movement of the object or the body. And here the specialty is that the movement of the body is only taken into consideration. We will not go behind why it is moving and what are the different forces acting on it, and we call it as it's a kinematics. So it is a movement of the body where the reason behind the movement or the force is not taken into consideration. Whereas in dynamics, we'll study about the movement of the body itself. It is something related to kinematics itself. But here the movement is studied there with taking into consideration of the forces acting on that particular object which causes that movement. So this is what the difference between kinematics and dynamics. So this is all about the branches. Now we are moving on to the next topic. The next topic is distance and displacement. So what is the difference between distance and displacement? So here comes another thing. Then you can see here is Shyam. This is Shyam there, and Shyam want to move from this particular point A to B. Then he want to move to C. Okay, let it be 10 meters and this is be 5 meters. So this is a scenario. What is the total path covered by Shyam? What is the total? How can you calculate the total path covered by Shyam? It's simple mathematics. That is, the total path is equal to the sum total of 10 plus 5 meters, that is 15, meters. So this is a total path covered by. Now, what is my position change? The total path covered is nothing but the distance traveled. The elaborated version of this distance and displacement is given in my 9th standard. You can check out the playlist of 9th standard where the correct elaborated portions are given for distance and displacement. Kindly check the playlist and see if you have any doubt. You can just go through that 9th standard topic and you can find it out clearly. So distance is nothing but the total path covered by an object, and here we can say it is 10 plus 5, that is 15 meters is a total distance covered. And now another question comes. So what do you mean by displacement? What do you mean by displacement? Displacement. So here, how can I calculate the displacement? So before starting this displacement, you need to know about the physics behind displacement. Displacement means change in position. So in the beginning, where was this particular person placed? And after some time, at the final point, where is he? At the final, initial point and final point are important here. At time t1, Shyam was at point A, and at time t2 Shyam is at point C. That is, initial point is A and final point is C. So here, what is the difference or the change in position? So change in position is this one, right? We will not take the total path covered. We will say the change in position is from A to C. This is a change in position. So how can I calculate change in position? Simple Pythagorean theorem. Here in this case, you can say that thing it is 10 and this one is 5. So it is root 10 square plus 5 square. So you can say that thing it is what? Displacement is what? 100 plus 25, that is root 125. This is the displacement. I hope that displacement is clear now. For those who haven't got it clear, I will explain one simple thing. That is, here is point A and here is point B. You can just move from point A to B in different directions, right? So let this be one direction. I can also use this path. I can use the straight line path and all and reach from point A to B. So here, distance is a total path covered. That means I can use this path 1, I can use path 2, I can use path 3. So there is no specific direction for the path to be covered. That is, from A to B, I can take any direction. And we call it as what? The path covered, otherwise is known as what? Distance. Whereas the shortest distance or line, straight line is known as what? Displacement. Why? Because we can say it is the only change in position. This distance displacement will be straight line. So it is the shortest path, and here the direction is specified. So we can say distance is a which type of quantity? It is a scalar quantity, whereas displacement is what? It's a vector quantity. Why? Because both magnitude and directions comes into play, whereas in the case of distance, only magnitude is important. There is no specified direction, so we call it as what? It is a scalar quantity. So this is about distance and displacement. And one more inference is there. In the case is that here, just check out this particular diagram. Here you can see that distance and displacement can be equal. If I'm taking I want to cover from A to B and I'm taking the second path, then my both distance and displacement are equal. So it is the shortest path. Whereas if I'm taking a first or third, the distance is greater than displacement, will be always greater than or equal. Don't forget. So I hope that you got the point about distance and displacement. So that's all for today's class, and I hope that you got the points. And next class we'll just go with the basic informations or the basic ideas about this particular chapter, and slowly we'll move into get into that particular pace. So we need your support by your like, share, comment and subscription. So stay tuned. So we'll see you in the next class. Goodbye and have a nice day.